Welcome to the DIY Honda Garage channel. The DTC code P0406 indicates that there is a high voltage condition in the EGR Valve Position Sensor circuit. EGR stands for exhaust gas recirculation, which is an essential component that helps to lower nitrogen oxide emissions and improve engine efficiency. This issue can affect vehicle performance and lead to increased emissions. The EGR Valve Position Sensor itself is located within the EGR assembly, and it's responsible for providing the engine control module, ECM, with data on the position of the EGR valve. A high voltage reading suggests a malfunction within this sensor, which may cause the engine management system to miscalculate the optimal timing for the EGR operation. In this case, proper troubleshooting methods must be employed to accurately diagnose and rectify the issue, minimizing potential performance degradation and ensuring compliance with emission standards. DTC P0406 specifically points to a problem with the EGR Valve Position Sensor circuit, meaning high voltage levels are being detected when they shouldn't be. The EGR Valve Position Sensor, known by the acronym EGR VLS, translates the position of the EGR valve to a voltage level that the powertrain control module, PCM, can utilize for engine management. When the voltage exceeds specified limits, it indicates a fault, leading to the PCM potentially limiting the EGR function to prevent engine damage or excessive emissions. The EGR Valve Position Sensor is located within the engine bay, directly associated with the EGR assembly, which recirculates exhaust gases back into the intake manifold. High voltage in this context usually means that there's excessive current flowing through the sensor, triggering the DTC. This malfunction could result in less efficient engine operation, as it may interfere with the engine's combustion process. The possible causes of DTC P0406 include a faulty EGR valve position sensor, wiring issues, or even a malfunctioning PCM. If the EGR valve position sensor itself is damaged or malfunctioning, it can send incorrect voltage readings to the PCM, resulting in this DTC being set. Wiring issues could manifest as frayed or damaged wires, leading to short circuits, which would cause the high voltage readings observed. Additionally, the PCM, which is the brain of the vehicle's engine systems, could be malfunctioning, unable to properly interpret input from the EGR valve position sensor. Detecting one of these issues requires a systematic approach to pinpoint the exact source of the high voltage signal. A thorough inspection of the EGR system, including the sensor, wiring, and connections, is essential to determine which part is at fault. When DTC P0406 is triggered, several symptoms may be noticeable. The most common sign is the illumination of the check engine light on the dashboard, alerting the driver to an underlying issue. Additionally, drivers may experience poor engine performance, such as reduced power, rough idling, or hesitation during acceleration. The vehicle might also exhibit increased emissions due to improper EGR operation, potentially leading to failing emission tests. Another symptom to note is a change in fuel efficiency, as the EGR system plays a vital role in regulating the combustion process. In essence, while some of these symptoms could be attributed to other issues, their presence in coordination with DTC P0406 signals a higher likelihood of problems with the EGR valve or its associated circuitry. In the first troubleshooting step for DTC P0406, the vehicle must be turned to the on mode without starting the engine. This allows the technician to access system parameters using the HDS, which stands for Honda Diagnostics System. At this point, it is crucial to check the current conditions of the EGR valve position sensor. Specifically, the voltage signal generated by the sensor should be more than 4.88 volts, as this is the established threshold for normal operation. If the voltage is above this threshold, it confirms the presence of a fault, and you should proceed to the next troubleshooting step. Conversely, if the voltage matches or is below the threshold, the system may be operating correctly at that moment, indicating an intermittent failure. In such cases, a closer examination of EGR system connections and terminals may be necessary. For the second step in troubleshooting DTC P0406, the first action is to turn the vehicle to the off mode. This is crucial for safety and prevents damage while working on the vehicle. Next, the technician disconnects the EGR valve 5P connector to allow for accurate testing. After removing the connector, the vehicle should again be switched back to the on mode. The next step involves checking the voltage readings between specified test points on the EGR valve connector. Specifically, you will measure the voltage between test point 1, which is the second terminal of the EGR valve 5P connector, and test point 2, which is the third terminal. If the voltage measures approximately 5.0 volts, it indicates that the EGR valve is indeed faulty, and replacing the EGR valve should be the next course of action. If not, further investigation is warranted. In the final troubleshooting step for DTC P0406, ensure that the vehicle is turned to the off mode for safety. Then, the SCS line, which stands for short circuit, should be jumped using the HDS. After waiting for more than a minute and ensuring the SCS line is active, the technician should proceed to disconnect the PCM connector C, which consists of 51 pins. Once this is completed, the next step is to check for continuity between key test points. Specifically, you will measure continuity between terminal number 3 of the EGR valve 5P connector and terminal number 33 on the PCM connector C. If continuity is confirmed, it signifies that the wiring, specifically the SG1 wire, is intact and undamaged, suggesting that the issue may need to be traced back to the PCM or other components. However, if continuity is lacking, it indicates a break in the SG1 wire that would need to be repaired for system integrity. After completing all troubleshooting steps for DTC P0406, it is critical to conduct final repair verification to ensure that the incorrect high voltage condition has been rectified. Begin by rechecking the overall functionality of the EGR system to confirm that it operates as intended and that any replaced components are properly functioning. Following this, clear any DTC codes from the vehicle's PCM, which refreshes the system and removes the previous fault codes. It's also advisable to perform a test drive under various conditions to monitor how the vehicle responds in real time. Monitoring for any reappearance of the check engine light and confirming that the vehicle performs optimally is essential to ensure a successful repair. If the code does not return and performance is enhanced, the repair can be deemed successful. If issues persist, further diagnosis will be required to identify other potential underlying problems. To minimize the risk of encountering DTC P0406 in the future, implementing a preventive maintenance routine for the EGR system is advisable. Regular inspections can identify early signs of wear or damage to the EGR valve and its position sensor, which can help prevent malfunction before it becomes a significant issue. Additionally, it's important to routinely check the wiring and electrical connections associated with the EGR system for signs of fraying or corrosion, as this can lead to intermittent issues or complete failures. If any worn parts or degraded connections are found, timely replacements should be made to maintain system integrity. Preventive maintenance serves the dual purpose of ensuring that the vehicle operates efficiently while also prolonging the component lifespan, ultimately saving costs associated with repairs and further troubleshooting in the long run. In summary, DTC P0406 denotes a high voltage condition in the EGR valve position sensor circuit, pointing to possible malfunctions within the EGR system. Given the EGR's crucial role in reducing emissions and enhancing engine efficiency, addressing this error code is vital for optimal vehicle performance. Effective troubleshooting steps include verifying parameters, disconnecting components for testing, and ensuring wiring integrity. Each of these steps is designed to systematically isolate the cause of the high voltage signal. Through diligent work and attention to detail, mechanics can either resolve the issue or identify the need for component replacements effectively. Additionally, implementing preventive maintenance can safeguard against future occurrences of this DTC, ensuring ongoing vehicle reliability. Please like and subscribe to the channel. See you next time.